right, so here we are at lesson 2. We are going to talk about solids, liquids, and gases. I'm sure you've heard those words before. So one thing I want to kind of talk to you about is that balloon that was on your worksheet from the last lesson. So in that balloon, there are different properties, but specifically we're going to talk today about the gas that's inside the balloon. What is that gas? Well, it's air, right? If you blow it up, you're going to put air in it. Okay, so air is a gas that fills up that balloon, okay? So if we look here, we have a couple balloons. They're filled up with air, so there's a gas inside of those. All right. Also, it wants us to look for solids. Solids mean they're solid, okay? If we look at the picture, there are several solids up here, but there are some that just right there. You know they're solid. The plate, the napkin, the fork, the cup, the balloon is solid, okay? You can manipulate it, you can bend it, you can move it, but it's solid, okay? If you drop it, it's really not going to change its shape, all right? So those are the solids. If we look for some liquid in that picture, well, the drink inside the cup is the liquid. All right, so we have a liquid there. Let's see. Maybe, I don't know. Maybe if we look on the next page, there might be something on the next page here. Let me pull that up real quick. I hate that I can't just, show you the page and be done with it. Can't get them both to come up at the same time on this program. Oh, the punch. The punch is in the bowl. Yeah, that's definitely a liquid. Yeah, for sure. So you have the cups that have the punch in them, and then of course you have the punch itself. So yeah, that's silly. All right. So on this page here, we have our planet diary. It says, did you know? So I'm going to read this to you. Oh, it's a couple swans. Swans are so pretty. What makes a thermometer work? It works because of the properties of liquids. A liquid takes up less space when it's cooled. It takes up more space when it's heated. So the liquid inside most thermometers is either alcohol or mercury. As I said before, the red one that I had was alcohol. Okay, it's just dyed red so you can see it easier. The liquid goes up in the tube when it's warmed, and it goes down when it's cooled. It has to be extremely cold for alcohol or mercury to freeze. And when I say extremely cold, we haven't ever been there. You might have thought it was really, really cold, but it hasn't been cold enough for that to happen yet. All right, so water freezes at 32 degrees Fahrenheit. Okay, so 32 degrees. 32 degrees is freezing. All right. I want you to write why water would not work in a thermometer. Why couldn't we use a thermometer filled with water instead of alcohol or mercury? Why couldn't we? Write your answer down here. Why couldn't you use water instead of alcohol or mercury? I mean, because water's safer, right? Mercury is very dangerous. And alcohol, well, it's not as dangerous, but let's face it, water's a lot easier to use. So why couldn't we use water in a thermometer? Yeah, because at 32 degrees, it would freeze, and we wouldn't know the temperature after that. So if it went below 32 degrees, the thermometer would stop, and chances are the thermometer, since it's made of glass, it would break, right? That'd be a bummer. So, no, wrong way. Let's go. Boys and girls, I am so sorry. It's being difficult. Listen to page. There we go. Let's focus on solids, shall we? So, remember the words to know are going to be solids, liquids, and gases. We're going to focus on solids for a minute. Everything around you is made of matter. We've already discussed that. Everything is made of matter. It has to be one of 3 states. It's either solid, liquid, or gas. It's one of those 3. Okay? A a matter that keeps its own size and shape. So when I told you like the paper plate, if we drop it, it's still going to keep its same size and shape. It's not going to change. Solids take up space and have weight. Look at the picture. Each object in the box keeps its own size and shape. These are all solid materials. Okay? Now, you're to draw one more solid that you might put in an art box. So think of something that might be missing from this box, and I want you to draw it down there. Okay? Think about a solid. Now, you're not going to put water in there. That's not a solid. Think of something solid that could go in this box. So if you wanted to take this art box to Grandma's, you could transport it easily. What is something solid you could put in there? When you're finished with that, I want you to go back up here and underline the 3 states of matter. Here they are. Solid, liquid, gas. There's those 3 states of matter right there. Okay? So what is a solid? A solid is matter that keeps its own size and shape. Okay? That's what it is. Let's talk for a minute about these materials in the art box. They're all solid, but think about their properties for a minute. They're all different colors. They're different sizes. They're different shapes. And, let's think for a minute, besides the size, shape, and colors, they're going to have different, they're going to have different textures. Look at the brush. The brush is going to have a different texture than these oil pastels. These oil pastels are going to be different than the watercolors. The watercolors are not going to feel the same as tape, right? Tape's going to be sticky. So think about that too. There are properties that go along with your solids. Okay? So that's the solids. Let's think about liquids for a minute. Let's move on to the next page. We'll think about liquids. With liquids, what are some liquids that you might use every single day? Go to page 26. What are some liquids that you might use every single day? Water should be the number one, right? Milk, juice, maybe even dish soap or hand soap, right? It's a liquid. Liquid soap unless you use bar soap, and then it's a solid. Difference there. All right? But liquids are matter that does not have its own shape. Okay? So if you have milk in a cup and you knock it over, is the milk going to keep the same shape as the cup? Heavens, no, it's going to spill everywhere. Liquid takes the shape of its containers. So if it's spilled, it's going to go everywhere because it doesn't have a container to hold it in. Container means to contain, to keep in, right? All right? Water is a liquid. Suppose you pour water into a jar. The water will take the same shape as the jar. Look at this picture. Suppose you pour the water into the funnel. The water changes to the shape of the funnel. Okay? As the water goes down, it's going to go through the spiral shape. So it's changing its shape again. It's no longer a funnel shape. Now it's a spiral shape, right? As it goes down the tube, it ends up in this square. So now it's the shape of the square. So the water just keeps taking on the shape of its different containers. Okay? So looking at page 27, how are solids and liquids different? How are solids and liquids different? How are they different? How are solids and liquids different? Well, if you look back on page 26, a liquid takes the shape of its container. Okay? So on page 26 it tells you that a liquid takes the shape of its container. If we look back to the previous page, it says that a solid keeps its shape. Okay? So, how are solids and liquids different? Solids keep their shape. Liquids take the shape of their container. In this box, you need to draw 2 shapes that the water took the shape of. So the spiral, the funnel, the box, the don't know if that's a hexagon or an octagon. 1, 2, 3, 4, 5. So it's a hexagon. So draw two shapes that the water took the shape of. Okay? Now here's a home lab. You can totally do this at home. Put some ice cubes in a bowl. Fill the bowl with water. What happens to the solid? What happens to the liquid? Might want to put it in something so you can measure it. Just a hint. Okay? If you do that, remember that the water will take the shape of the container that you're using. Okay, so just keep that in mind. All right. So we're going to go on to the next page, and we're going to talk about air. What is air again? We have a solid. We've talked about liquids, and now we're going to talk about gases. Yeah, air is a gas. As you blow up a balloon, what happens to the balloon? You're blowing it up, blowing it up, blowing it up. Yeah, it gets bigger, right? The air expands the balloon. So the balloon ends up changing its shape, okay? And if you squeeze a balloon, well, it's going to change its shape again because you're squeezing it. You're putting pressure on it. So gas is a matter that does not have its own size or shape. Gas takes the size and shape of what it's in. Gas takes up all of the space inside the container. The bubbles, I bet you've blown bubbles. The bubbles are filled with gas. You know that air is all around you, and air is made of gases that you cannot see. All right? So, how are liquids and gases alike? Now, we just talked about solids and liquids. Solids keep their shape. Liquids take the shape of their containers. So how are liquids and gases alike? Well, both liquids and gases take the size and shape of what it's in. Specifically the shape. Does water take the size of the container? No. Water's only going to be in as much as you put in. Air is going to take up the rest of the space. Okay? But to compare them, liquids and gases are alike because they take the shape of whatever it's in. Okay? Down at the bottom, you should see a bounce house, right? What's inside the bounce house? What makes it blow up? Yeah, there's a gas. It's air. There's a gas inside, right? Now, it says to draw an arrow to the gas in the bubble, but you can't see the gas. So I guess you're just going to draw an arrow to one of the bubbles on page 29. And just as a reminder, what shape does gas take? Gas takes the shape of whatever it is in. Okay? Liquids take the shape of the container they're in. Solids keep their size and shape. Gases take the shape and fill up the container that they're in. Okay? So keep those in mind when you're talking about solids, liquids, and gases. You have a worksheet that should say Chapter 1, Lesson 2. And this worksheet discusses solids, liquids, and gases. I'm looking at my book here with the worksheet. You're going to draw a line from solid to the definition of a solid. If you don't remember, can you look back in your book? Yes. Number 2, you're going to draw a line to the definition of liquid. And number 3, you can draw a line to the definition of gas. Now, number 4 says, give one example of a solid, a liquid, and a gas. Use a sentence. Tell me what a solid, liquid, and gas is. Give me an example. There's probably a material that does all three. Just saying. And then at the bottom, it's going to tell you what happens if you put these things in a container. So what's going to happen to a plastic ball if you put it in a container? I got a ball. What's going to happen if I put this in a container? What's going to happen to the ball? Anything? It's a solid. What's going to happen to apple juice if I put it in a container? So I'm thirsty. I'm going to pour apple juice in a glass. What's going to happen? And what about all this air that's around me? What happens if I put it in a container? What does it do? Hint, hint. It's on this page for gas, for the air. Okay? If you have questions or need some help, let me know. Have fun. Go blow some bubbles.